to our live coverage of what is probably not going to be a launch of the Parker Solar Probe. I clicked this stream on just after they had the weather folks saying that we're looking currently at about, 20%-ish likelihood of launch because weather. So they have clouds, they have grossness, they potentially don't have a launch, but we're here until they actually cancel the launch. So is that 70% chance of cancellation? So am I reading it wrong that it was 20% against? That's entirely possible. Okay, that's much more favorable. That's much more favorable. It is true. It is true. There is a chance that, so it's probably 80 then, because the number they just showed was 20 POV. Let me Google that. Launch 20 POV. Weather. Launch weather. Not helping me, giving me historical information. Here they go anyways. Nope. Here they don't go. There.
From NASA's Kennedy Space Center in Florida, you're watching live coverage of the Parker Solar Probe mission to unlock mysteries of the sun's atmosphere. Good morning, I'm NASA's Marie Lewis. Thanks for waking up early this Sunday morning for our second launch attempt. We have team coverage of today's launch from NASA's Torrey McClendon at a viewing area near the iconic Vehicle Assembly Building, NASA Edge's Franklin Fitzgerald and Blair Allen, and NASA's Josh Finch and Mick Waltman at the Mission Director Center. We'll have in-depth interviews on everything you need to know about Parker Solar Probe and how the weather is shaping up. But first, Parker Solar Probe is targeted to launch at 3:31 this morning, Eastern Time, from Launch Complex 37 at Cape Canaveral.
So welcome everyone. I'm just going to talk over this particular woman. We are all here right now waiting to see what happens with launch of the Parker Solar Probe. And this is basically a remix of last night. We have a 65-minute window for launch. This is the period of time during which the Earth is pointed at just the right direction for the probe to be able to take off the planet and head off towards its next rendezvous with Venus. If we let the Earth move too far around in its rotation, we won't be pointed the same way, or at least Florida won't be pointed the same way, and we won't be able to launch correctly. So thank you, all the follows. Thank you for the raid. Welcome everyone who's new. I am Dr. Pamela Gay. I am a part of the CosmoQuest team, and I am here to, welcome you to share the launch experience with us. I am here to answer all your questions and to just chat and be anxious and cheer everything on together. So I'm now waiting to see if we go to weather. So here we go.
Waltman and Kennedy's Mission Director Center for an update. Hi, guys.
Good morning, Marie. I'm Joshua Finch, and I'm here with Mick Woltman. Good morning, Mick.
Good morning, Josh. I'm happy to be here on behalf of NASA's Launch Services Program.
And we're happy to have you. This is our second launch attempt for NASA's Parker Solar Probe on the Delta IV. Can you tell us a little bit about yesterday, why we scrubbed, and what happened right after that?
Yeah, absolutely. A lot of work's gone on by the launch team since yesterday's launch attempt. They've been working on a few things. The gaseous helium bottle pressure limit that resulted in yesterday's morning scrub was evaluated by United Launch Alliance and the NASA launch teams for today's op. The teams will continue to monitor that limit. However, they did place in some new limits for the port and starboard common booster cores. So they'll continue to watch that today. After detanking yesterday, the team did perform inspections of the launch vehicle bond-on foam insulation, or BOFI. Due to the cold temperatures achieved during cryogenic tanking yesterday, minor repairs were required in some of the interface areas. They made those repairs, verified them this morning. They're ready to support today's launch tanking operations, and then we began with moving the MST earlier today to get ready for a launch.
That MST, or Mobile Service Tower, standing behind the Delta IV Heavy rocket on the screen. The teams also just received a weather briefing from the U.S. Air Force 45th Space Wing. The launch weather officer for today's mission is looking into a whole host of weather-related details, such as wind speed, cloud coverage, and more. And launch teams need to know this before committing to launch. That report came back pretty great. Our probability of violation is now just 5%. That means we are 95% go. Winds 6 knots out of the southwest. The temperature is at about 78 degrees. Those concerns that we were initially looking at with the anvil clouds, it doesn't look like any of them are going to drift into the launch area today, so we are really good on cloud coverage for today. So a good news story with the weather improving for us. And Mick, can you tell us a little bit about the Delta IV Heavy with the additional third stage that we're seeing on our screen now?
Yeah, absolutely, Josh.
Okay, so I'm going to talk over the description of the Delta IV since we went over a lot of that yesterday. So at this point, we have first of all learned I had it completely backwards on what the 5% we saw at the beginning was, and that does make me quite happy. Now, you may have seen me kind of making faces when they were going over the things they had to fix. If you look at this rocket, thank you so much. If you look at this rocket, you'll see all of these orange unpainted regions. These regions are insulation that surrounds the liquid fuel, which is cooled gases, things like, well, liquid oxygen. And that insulation isn't all that different from the spray caulking that you might use to insulate your own home. It's, of course, like a heavier duty version, but that tendency it has to crack and shear off when it gets super cold totally applies to these rockets. And so what they were saying is, after being exposed to all the cold of the interior of the rocket, some of that insulation needed to be repaired. Now, the reason that this triggers me to, without even meaning to, make ugly face is it was falling foam like that detached from the external tank on the Columbia mission back in, I believe it was January of 2003 rather, that caused the Columbia to get damaged and explode on landing. Now, the nice thing is, those rockets don't have to come back. They don't land. They don't do anything exciting. They just detach and, I believe, fall into the sea. So we're good. Okay, looking to see what questions we have. Hey there, Com10 Gamer. Okay, so here we go.
Is just the first step. Let's talk about what it's going to do on its own in space. Did you know our models for predicting what our star is going to do are incomplete? We can't fully understand the sun's physics if we've never been there. Here's how Parker plans to change the game. First, it's going to get up close and personal, flying just 4 million miles away from the sun's surface. And that may not sound so close to you, but if we put Earth and the sun on either side of a football field, Parker is going to tuck and run all the way to the 4-yard line, where temperatures can reach 1,000,000 degrees Fahrenheit. But don't worry, Parker's equipped to handle those kinds of temperatures, and it will use just a single gallon of ordinary water to do it. If you can believe it, the spacecraft's thermal regulation system is designed to collect and dissipate heat just like a car radiator. That way, we can stay where the action is, orbiting the sun's corona in order to figure out why it's even hotter than the surface itself. But the corona isn't just harmful to our probe, it's dangerous for us as well. That's because of a little something called the solar wind, discovered by none other than our spacecraft's namesake, heliophysicist Eugene Parker. The solar wind spews harmful solar particles way beyond Pluto, and no one knows exactly what accelerates it so far, so fast. That's why Parker is designed to hang out near the origin of this wind, so we can finally figure out what it's doing and what it could potentially do to Earth.
Thanks, Jessica. Data collected by Parker Solar Probe will
I don't mean to keep blocking this woman, but it just keeps happening this way. So to get at the questions that I'm seeing in here, there's a good one just a moment ago. And welcome all you new people that haven't been here before. I'm so glad to see all your new names. So I know there was a question. And it was one that I really wanted to answer, and now I can't find it. Please at me. When will it orbit? Sixth Sense asked, when will it orbit? It's actually going to be in orbit just a few minutes after launch. And thank you so much, Torrin, too, for the follow. So the Delta 4 Heavy that they're launching on is going to go straight from the surface of the Earth down in Cape Canaveral, Florida, launch up through our atmosphere, go through low Earth orbit, go through geostationary, and just keep going. This mission isn't going to do a once around the planet. It isn't going to do, in fact, anything other than leave us behind. So as soon as it's away from the Earth, it's orbiting the sun just that fast. Now, there are going to be some rocket engine firings and other things that are happening as it heads its way out of our system. Thank you so much for the bits, Com10 Gamer. Oh, wow. Well, Uncle Bill, so they don't want to let H2 vent off too freely because it's just like entering a room where you have a gas stove that isn't lit but has been turned on. All of that gas venting into the air around you is going to make everything kind of likely to explode. If they end up surrounding the launch with, well, stuff that would like to explode, that's kind of bad. So yeah. It's true, there's always some H2 around. Okay, so we're going back to the Mission Directorate Center.
most powerful rockets, guys.
Thank you, Marie, and welcome back to the Mission Director Center. It takes a team to be able to launch the Delta IV Heavy this evening. Teams from NASA, United Launch Alliance, the U.S. Air Force, and more. Mick, can you characterize the teamwork that goes into doing something like this tonight?
Yes, Josh, as you said, it's a team effort to get a mission this far prepared for launch. Mission teams working around the country have prepared the rocket and the spacecraft for this morning's launch attempt. Teams from United Launch Alliance stationed in Denver, Colorado, from their production and manufacturing facility in Decatur, Alabama. We have spacecraft from NASA's Goddard Space Flight Center in Greenbelt, Maryland, John Hopkins Applied Physics Lab in Laurel, Maryland, and of course right here in Florida, the team worked on the spacecraft at Astro in Titusville, and here at Cape Canaveral Air Force Station inside the Mission Director Center at Hangar AE and the Delta Operations Center.
And that's a live shot inside the Delta Operations Center that we just saw there, where the NASA launch manager Omar Baez and the launch director Lou Mangieri from United Launch Alliance are working with teams toward a liftoff today of the Delta IV Heavy. Earlier in the countdown, the team received a weather briefing from the Air Force, which improved the weather forecast to 95% go, only a 5% probability of violation. But the U.S. Air Force not only briefs the launch teams of weather which could impact a launch, but they also keep the launch teams aware of other launch considerations on the Eastern Range, including telemetry coverage for public safety. And they update the teams on COLAs. Mick, can you talk about COLAs?
Yeah, your reference to COLAs, or collision avoidance analysis, which is performed by the United States Air Force for public safety and the rocket safety, actually. One of the considerations they analyze is objects in space. For example, other satellites around the Earth that could be in the flight path of the Delta IV Heavy this morning. With a 65-minute window today, there could be some small cutouts, what we refer to, where the launch teams would not be able to lift off. This analysis is started days out. The final report is provided to the launch manager, Omar Baez, on the day of launch to help determine today's T0 for the launch attempt. We've heard there's no COLA cutouts for today's launch attempt, so we're still on schedule for a 3:31 a.m. launch.
And we do have an hour and 5-minute window should launch teams need more time, but we're at the beginning of the window right now. You're looking at live shots of the Delta IV Heavy rocket. And Mick, can you tell us a little bit more about what's happened up to this point?
Yeah, right now we're in the T-4 and holding. We've got about 12 and a half minutes left in this built-in hold. Teams have been working to get cryogenic tanking completed. Those operations are finishing up with topping and maintaining continuing. Things are progressing towards that 3:31 a.m. liftoff, as I mentioned before. We do have that 65-minute or hour and 5-minute window that you had talked about for tonight's launch attempt in case something does come up. But right now, all things are go and looking good for a on-time liftoff at 3:31 a.m.
So a lot going on here in the Mission Director Center, and we'll keep listening in to the launch teams as they prepare for liftoff. But for now, we'll go back to Marie.
All right. Thank you, gentlemen.
I've been totally talking to you with no mic. No mic. I'm sorry, I screwed up. So thank you, Heptacular Raptor. Let's continue to light up the chat for Heptacular Raptor. I do totally need more coffee. I don't have it. Thank you, Larry and Weird. That's more Heptacular Raptor. Hip, hip, hurrah is indeed the correct response. So what I was explaining, and I'm going to explain it again because mute button got me. Thank you, Deadpool, or more Heptacular Raptor. Thank you all so much. So this mission is off to study the sun, but it has instruments on board that are capable of so much more than just observing the sun. I believe it's the Whisker white light camera is not going to just take beautiful images of the sun and corona to send back to us. It's also going to observe Venus. It's going to observe Mercury. It's going to look for sun-grazing comets. It's going to look for asteroids in the inner part of our solar system and study the dust. All these different things are truly scientifically amazing and are going to, well, allow us further study of these objects we just don't know that much about. So, you guys are all the best. I just kind of love my chat, and thank you for all of your support as we hopefully prepare for launch in just 22 minutes, not 22 minutes, 12 minutes, in just 12 minutes. So I believe at about the 10-minute mark is where they start to go through all of the checklists again. Yeah. So it used to be super accurate to say, let's get this candle lit, because candles are solid fuel, the wax, and you have a fuse and it burns through, and well, that's how solid rocket boosters work. And this mission does have not just one candle to light, but multiple candles to light with those 2 solid rocket boosters on either side. Now, the main external tank, well, the central tank in this case, these are all stealing and adapting from technology that we had from prior missions. This is filled with super cool liquid gases. So there it's more like get this lamp lit. Okay, we are returning. Nope, we are just looking at the Parker Solar Probe. Now, thank you so much, Fenmill. Fenmill, you know I like you for way more than your bits. Those aren't solids. Did I mix my rockets? It's entirely possible that I mixed. You're right. Those are liquid. That's why they all have the insulation. I lied. I didn't mean to lie. I combined my missions. The SLS system has solid rocket boosters. This is the Delta IV. You're right. It does have a solid third stage. I believe that they're using a LOX system, so liquid oxygen. It's kind of easy to use liquid oxygen. So the man that they're showing on the screen here, Dr. Eugene Parker, he was the first person to really figure out that our sun has amazing storms that lights off coronal mass ejections like you see here in this image. These coronal mass ejections can interact with our planet's magnetic field, lighting off amazing aurora that we can see at night. But unfortunately, those same things that generate amazing aurora also oscillate our Earth's magnetic field, and this can affect the communications and can also generate electricity in wires that, well, can take down our Earth's power grid. We've also had a case with hurricanes last summer where we lost communications with Puerto Rico during the critical hours of Maria encountering Puerto Rico. And this was all caused by a coronal mass ejection interacting with our atmosphere. So this is a woman from the, okay, let's go to this.
And liftoff. Liftoff of the United Launch Alliance Delta IV Heavy rocket.
3 Delta IV RS-68A main engines ignite and generate more than 2.1 million pounds of thrust to lift the rocket away from the pad. The Delta IV reaches Mach 1, the speed of sound, at 1 minute 18 seconds. At 3 minutes 56 seconds, the port and starboard booster engines shut down. 2 seconds later, the boosters are jettisoned. At 5 minutes 36 seconds, propellant levels deplete and the main engine shuts down. 7 seconds later, the Delta IV separation system activates to release the first stage. At 5 minutes 55 seconds, the first Delta cryogenic second stage, or DCSS main engine burn, begins. At approximately 6 minutes 5 seconds, the payload fairing is jettisoned. At 10 minutes 37 seconds, cutoff of the DCSS engine, or MECO-1, occurs. At 22 minutes 25 seconds, the DCSS main engine is restarted for the second burn. Approximately 14 minutes later, second cutoff of the DCSS main engine occurs. Following a 30-second coast phase, the third stage is separated. 20 seconds later, the third stage is ignited. Approximately 1 minute 29 seconds later, burnout of the third stage solid rocket motor occurs. At 43 minutes 10 seconds, the third stage releases NASA's Parker Solar Probe spacecraft on its journey to the Sun.
Alyssa, a lot happens after T0, but can you tell me what's happened up to this point and what's about to happen in the count?
Yeah, so the rocket is ready to go at this point. It's fueled. The people on console all their systems have been checked out and are ready to go, and we're about to enter into a terminal count poll conducted by the launch conductor, where the launch conductor will poll each engineer and verify that their systems are in fact ready with a simple go, and that indicates that the launch is ready and Delta is ready to fly.
And we're just about 18 seconds away from that poll. Live on your screen, you can see the Delta IV Heavy rocket with the additional third stage at Space Launch Complex 37 on Cape Canaveral Air Force Station, and we'll listen in to this poll in about 5 seconds.
Status check to proceed with terminal count. First stage systems, propulsion. Go. Hydraulics. Go. Locks. Go. LH2. Go. Second stage systems, locks. Go. LH2. Go. Third stage systems, third stage vehicle manager. Go. Electrical systems, airborne. Go. Ground. Go. Facility. Go. RFFTS. Go. Flight control. Go. Com. Go. GCQ. Go. Operation support. Go. Pneumatics. Go. Umbilicals. Go. HAZGAS. Go. ECS. Go. Red line monitor. Go. Quality. Go. Op safety manager. Go. ULA safety officer. Go. Vehicle system engineer. Go. Anomaly chief. Go. Range coordinator. Clear to proceed. Launch director. You have permission to launch. Proceeding with the count. MEQ, established swing arm lock pins pulled. Active.
And we just heard the poll with all stations reporting that they're go for
Thank
launch.
you, Badman,
Alyssa,
for
we're
the
entering the final few minutes of the
Thank
count
you.
here, about 5 minutes and 45 seconds before we launch. And can you tell me what it means to United Launch Alliance to be able to launch the Parker Solar Probe?
So in about a minute 46, you should see that 4-minute countdown clock in the lower right begin to count down. They're just doing a few final minute checks, and they won't start it until the end of the 4-minute countdown coincides with the launch window. Just to explain it again, the launch window is triggered by when will our rotating planet have Cape Canaveral down in Florida pointed so that as the rocket launches, our planet's rotation gives it that extra energy, gives it that extra velocity, and as it exits our atmosphere, it is go. Okay, we're switching over to internal power.
All steps are complete prior to terminal count.
So the countdowns with holds is developed because it turns out human beings take variable amounts of time to complete checklists. And by putting these built-in holds in, they leave
And
the
we have about
hold
30
long
seconds
enough
remaining in our
to
hold
deal
in the
with
T minus
many
clock.
different kinds
After
of
that,
problems.
the L minus and the T minus
You
clocks
can't
will be
turn the
synced
clock
up. You're looking at a
backwards.
live shot of the
It's
Delta
just
IV Heavy
easier to be
rocket
able to hold
poised
the
for
countdown.
liftoff from Space Launch Complex 37 at Cape Canaveral Air Force Station.
Okay, and now we stare. We stare, and it does
And we'll pick up the
nothing.
count. 5, 4, 3, 2, 1.
T minus 4 minutes and counting.
We are
Minus
go.
355. Ground pyros enabled.
Now, we did stop last night after this point. Thank you, Shadow Breed, for the follow. And I will switch over to the big screen when I'm sure we are go. For now, I'm going to sit here, answer your questions, and enjoy everything with you. I'm waiting for all of the umbilicals to get undone, for the gangways to move away.
And once again,
25.
We're about 3 minutes and 20 seconds before liftoff.
Now, if they show us
And Mick, can you tell me what we have left to go in the next 3 minutes?
Yeah, the teams are securing LOX and LH2, liquid hydrogen tanking there. They'll be finishing that up, getting ready to go internal. You'll hear a call for spacecraft power to internal. They'll be
Shadowbreed,
arming
you
their
miss
flight
living there
termination
now,
systems and getting ready for launch.
but
And
you
then bringing the
wouldn't
Delta
if
IV
you were
heavy launch
there in
vehicle
August.
onto internal power to prepare for the final terminal count.
Minus 249.
And we are coming up very shortly on the verification of the spacecraft being on internal.
So last night we had two holds, or sorry, we had
CBC
two
LOX,
anomalies
flight
that they
pressure,
had
flight
to
level.
get through. And the second anomaly,
Minus
by the
230.
time they were done with it, there wasn't
NSC
enough
verified
launch window
spacecraft on
left.
internal power. Verified.
This is the scary wait part, because at any moment they could go, no. Come on, come on. They reset to 4 minutes
And we are
yesterday.
at T minus 2 minutes, 5 seconds, and counting. After liftoff, we'll be listening to the voice of United Launch Alliance, Patrick Moore, providing ascent commentary.
155. Launch sequencer start.
Okay, I'm going to switch over to the other screen. Now, if they show the bottom,
Minus
there.
140.
Doesn't it look like a Lego rocket?
137.
CPC LH2 at flight pressure and flight level. FTS armed.
I can never unsee this as a Lego rocket.
Minus 120.
LCU armed. FCS count started.
The fire woo
2
roo
minutes.
boo,
1 minute.
they're burning off
Engine
excess
stop.
hydrogen gas.
Rock report range status. Range green.
So they have to check the range to make sure that there's no
LCOVM.
no fishermen, kayaks.
Roger.
Range green.
Okay, we're still go.
LH2 secure at flight level.
40. Minus 30. Status check.
Go Delta.
Go PSP.
Come on, baby.
Minus 15.
Profi ignition.
10. 9.
Nine.
Sister start.
8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the Sun.
There we go.
3RS-68 look good in the full thrust mode.
Fentanyl, don't even joke.
25 seconds into flight. Chamber pressures continue to look good on all three
Thank you,
boosters.
Colonel.
Now 35 seconds in. Chamber pressure on the core booster is throttling down to partial thrust
It
mode.
looks so tiny. All you see is the
Response looks
little
good.
engines. The entire rest of the rocket is lost to the night.
Now 50 seconds into flight. Strap-on boosters look good in the full thrust mode. Core booster looks good in the partial thrust mode. Now 1 minute into flight. Vehicle trajectory looking good, right down the middle of the range track.
So Miko is main engine cutoff.
1 minute, 10 seconds into flight.
I'm glad you're here with us,
Coming up
Beth.
on 1 minute, 19 seconds into flight, max Q, maximum dynamic pressure, and Mach 1 Delta IV is now supersonic. 1 minute, 30 seconds into flight. Port and starboard booster engines continue to look good in the full thrust mode. Core booster looks good in the partial thrust mode.
So they will have to throttle back when they hit the
1
part
minute,
of the
45 seconds into
atmosphere
flight.
that exerts maximum force on the poor rocket.
Trajectory
bot
continuing
totally
to look good
agrees
right
with
down the middle of the
chat.
range track.
We have an amazingly well-programmed bot.
ACS press valve has been opened. ACS pressure response looks good. Two minutes, 10 seconds in. Strap-on boosters continue to look good in the full thrust mode. Core booster looks good in the partial thrust mode. And Delta 4 has gone to closed loop guidance.
So that star pattern that you're seeing, I don't know, but I'm pretty
2
sure
minutes,
that
30
that's an
seconds
effect
into
of
flight.
the lens. Thank you, Woo-Roo-Boo.
And at 2 minutes, 39
You're
seconds
always
into flight, the
welcome.
Delta 4 rocket now weighs just 1/2 of what it did at launch, burning propellant at a rate of almost 5,000 pounds per second.
Okay, I'm going to switch over to this screen. So,
And launch vehicle is now 33 miles in altitude, 49 miles downrange distance, traveling at
thank you, Woo-Roo-Boo.
4,500 miles per hour. 3 minutes into flight.
So it's
RS-68A engines in the port and starboard boosters continue to look good in the full thrust mode. Core booster looks good in the partial thrust mode. 3 minutes, 15 seconds into flight.
So that's all about the actual lens flare. No J.J. Abrams was required
Trajectory
for
continuing
this.
to look good down the middle of the range track.
So range track is the path over the Earth's surface that the rocket travels
Approximately
over.
2 minutes remaining in the boost phase of flight. Chamber pressures continuing to look good on all three boosters. Port and starboard booster in the full thrust mode. Core booster continuing in the partial thrust mode. And standing by for a strap-on booster throttle down momentarily.
So they're
Port
gonna
and starboard boosters have begun to throttle down.
They throttle them down and then deploy them
And we have
off the
jettison of both
sides.
strap-on
There
boosters.
they go.
Core booster is throttled back up to full thrust. Response looks good.
So what's kind of cool is, at least, I don't know what kind of camera
4
they're
minutes,
using
25
right now,
seconds into flight.
but many of these are using telescopes.
Upper stage lock system has begun boost phase chill down sequence. And 1 minute remaining in boost phase of flight.
No, Saman, that is unique to the Falcon rockets.
And upper stage fuel system has begun boost phase chill down.
Yes, Austin, I think you're right on that one. Hello, Gamer Charmed. Welcome. Thank you for the follow. So the way that they're getting the image that we're watching right now is there's a
5
telescope
minutes
that
into
is
flight. Just over
auto-tracking
30
on
seconds
the
now remaining in
bright
first
point
stage,
of the
first stage
rocket.
phase of flight. Core booster engine continues to look good in the full thrust mode. Vehicle trajectory continuing down the middle of the range track. 5 minutes, 20 seconds into flight.
Hey, Bill.
And standing by for core booster throttle down momentarily. Core booster has begun to throttle down. Standing by for BECO. And we have BECO booster engine cutoff, standing by for stage sep.
Okay, so they're going to drop the first
And we have good
engine.
indication of stage separation.
They're going to show us.
Ned is deploying. We have pre-start on the RL-10. And we have ignition on the RL-10 engine. Engine chamber pressure looks good.
Fenmill. That joke I have seen so many times, and it is still hilarious.
And we have good indication of payload fairing jettison.
Okay, so the fairing is the thing that protects the spacecraft from the Earth's atmosphere during
Now
launch.
6 minutes, 20 seconds into flight.
They dump it as quickly as possible so they're
And
not
with the
carrying
boost phase of
extra
flight
weight.
complete, Parker Solar Probe will now continue its journey to the Sun.
And she's escaped the Earth. I know it was named after a man, but spacecraft should be she's. It's a comic book illustration. It's a thing.
And it's 6 minutes 50 seconds into flight. RL-10 chamber pressure looks good.
Yeah, Uncle Bill, I don't know
Seeing
why
good
they don't
responses
like
on the
cameras.
upper stage RCS system. And after a brief review of booster performance, seeing very close to nominal performance on the booster.
So our Astro, it's more a matter of boats were traditionally
And this first burn of the second
female
stage will last
names
approximately 4 minutes 42
and
seconds.
protected
Now
by
7 minutes 30
the
seconds into
siren
flight.
at the front of the boat. And I just
About 3 minutes remaining in the
like the
first
idea
burn.
of women protecting all of the ships. Nominal has been said it's required at least once. Okay, so she's off. She's going. Next stop, Venus. And this will be one of the fastest spacecraft. Now, in order to get this speed, just like New Horizons, they launched on a big old rocket. Now, the Delta IV Heavy only is able to launch half the weight to low Earth orbit that the Falcon Heavy will be able to. But the way it accelerates during launch, and we're going to have to wait and see what the Falcon's capable of. It was believed that the Delta is capable of getting
And at 8 minutes 30 seconds into flight,
a larger
RL-10
Delta V.
chamber pressure continues to look good. Seeing very stable values on the upper stage LOX and LH2 tanks. ACS storage bottle pressure looks good. And vehicle body rates are very smooth.
So I don't know how long they're going to go. I know there's going to be an end. Well, here they go. The
Now
end
9
of the
minutes into
firing.
flight.
I'm confused that the Earth isn't changing in their graphic. But I'm also deeply amused. If you look, there's this timeline up here that is very similar to what we get from SpaceX. So it looks like the different companies are all learning from one another. No, one silent storming. It does not show the orbit. It doesn't show
And at 9 minutes
many things.
40 seconds into flight. Just under 1 minute remaining now in the first burn of the second stage. Second stage continuing to perform nominally. RL-10 engine performing well. Tank pressures look good. Vehicle body rates remain smooth.
That's a
10
good
minutes
point,
into flight.
bad man.
And about 30 seconds remaining in the first burn.
Fenmil, that's the best way to watch these things. So in case you didn't catch, 30 seconds left in this burn, and then she coasts for a while. I don't know how long the NASA coverage is going to continue. Let me look this up in another window.
And standing by for MECO 1 momentarily.
So they're saying main engine cut off for the main engine on Parker.
And we have MECO. Body rate smoothing out nicely. And now seeing upper stage ACS firings as expected. Now 11 minutes into flight.
So NASA TV schedule
And this will be approximately a 13-minute coast duration prior to MES 2.
is unclear about how long this is going to run. I'm guessing it's may run for the next 13 minutes. I'm not sure.
From the Mission Director Center, I'm joined once again by Alyssa Macbeth of United Launch Alliance. For those of you that are watching, we had an on-time liftoff today of the Delta IV Heavy rocket. And Alyssa, can you tell me how the launch went?
Oh my goodness, that was a beautiful launch. Just the sound and everything. Oh, it was great. It's looking good so far too. We saw good separation of the boosters from the main core and the booster from the second stage. Just experienced MECO 1. There's going to be 2 burns of the second stage, so that's coming up. The second burn, second engine start. And then in just approximately 45 minutes, we'll see payload separation. So everything's looking good so far.
Great. And can you tell me a little bit about your experience working with ULA and what it's like to work in a mission like this again?
Yeah. So I get to work with the innards of the rocket, the electronics, the avionics boxes, ordnance, pyrotechnics, all that kind of stuff. So working on a mission like this is something really special, to be able to get your hands on a view.
So at this point, I think we are all tired puppies. So I am happy to ask your tired puppy questions. So let me see what they say next. I think we're just going to watch this for a little bit. So yeah, she's coasting along. No big deal. It's a spacecraft doing the spacecraft thing.
Delta 4 upper stage is continuing the coast period prior to MES 2. Vehicle systems all performing nominally during this coast, seeing periodic thruster firings as expected. Tank pressures and body rates remain stable.
This animation is deeply disturbing because it looks like they're pivoting it to steer it back down to the earth. But they're not. I promise you they're not.
And a brief review of the performance from the first burn,
It
seeing
depends on how you
a fairly
speak,
close
Fenwell,
correlation
not
on
cute if it sounds like a
major
squeaky
orbital
toy.
elements. Performance appears to be pretty good.
I have the best chat ever. So there's going to be total gravity assists from Venus. This is why they're headed to Venus
From the
first.
Mission Director Center, once again, we had an on-time liftoff of the Delta IV
Yes,
Heavy
slingshot.
rocket. On your screen, you were seeing a live telemetry view animation of the rocket on its flight path. So things are looking pretty good at this moment as we're in a coast phase right now. And we'll go back to Marie Lewis for more on NASA's Parker Solar Probe. Marie?
All right, thanks, Josh. And I don't know about you, but here in the studio, we could feel the rocket rumble. And I know for our folks here on the
could
TV
not
side, that
feel
never
it.
gets old. We have Tori
Thank you,
standing
Barry.
by now with a very special guest. We've been talking about him the whole show, and Tori, we can't wait to meet him. Please introduce us.
We haven't got to hear
Thanks,
him
Marie.
yet.
I do certainly have a very special guest with me, Dr. Eugene Parker himself. Dr. Parker, you just watched the launch of the mission that bears your name. What was that like?
Well, I really have to turn from biting my nails and getting it launched to thinking about all the interesting things which I don't know yet, and which will be made clear, I assume, over the next 5 or 6 or 7 years. It's a whole new phase, and it's going to be fascinating throughout. I'm anticipating that the results will turn up basic information on why the corona of the sun is at 1 million degrees. That accounts for the acceleration of the solar wind. I'm just waiting for the data now, and the experts can get busy and sort it out, because there's an awful lot of data coming in, or will be a lot of data coming in. All I can say is, wow, here we go. We're in for some learning over the next several years.
That's right. So we'll definitely be anxiously awaiting that data and research. I also hear that this is the very first launch that you were able to witness with your own eyes. Is that right?
That's right. The video, of course, has supplied all of us with views of rocket launches, but somehow when you're looking at the real thing, it's quite impressive.
Nothing compares to the real thing, I would think.
Yeah, it's a little like the Taj Mahal. We've all seen pictures of the building and what a graceful structure it is. But if you happen to be in India and stop by that way, there's the real thing, and video and paintings and so forth just don't catch it somehow. Your mind is in a different state when you're looking at the real thing.
Well, we are certainly all honored to have you here with us this morning. Thank you so much for joining us.
My pleasure.
Marie, we'll go back to you.
All right, thanks,
That was
Tori. So great to
adorable.
have him here on the show. Understanding the sun will give us valuable information for future space missions. Mike Riskovich from Johns Hopkins Applied Physics Laboratory is live on set now with NASA Edge's Blair Allen. Blair?
Okay, so I'm going to go back to answering your questions right now. I'm kind of amazed at just how many exhausted scientists they have right now. Night launches are truly spectacular, but these are spacecraft people. They're not used to pulling the night shift like us observers. So the old man that we just saw interviewed is Eugene Parker. He, back in the 1960s, was the individual who discovered that our sun has weather on it, that it isn't just a steady state system that's boring to look at, but rather it has these flares and all these different activities that can interact with our own atmosphere, that can generate the aurora, can really screw up our power grid, can interfere with communications. And the Parker Solar Probe was named after him as it goes off on a mission to try and understand exactly how it is that, well, the sun's weather works. And we have a lot of major questions, like we have absolutely no idea at all. Well, no, we have small ideas. We don't have confirmation of ideas of why the corona is millions of degrees when the surface of the sun is only thousands. So Hanny's asking, what does the team do until September? They don't get to chill. I'm sorry, no. They're all in preparations now for their various encounters. They're going to be working on making sure that they have all of the data reduction software, which they haven't needed up until now, completely complete. They're going to be planning out exactly what images they take when, where on the different objects they're going to be observing. So now they're essentially choreographing how they'll use the instruments on Parker as they do flyby of Venus. So now we're going to talk about sampling the sun. So I'm going to switch over to this.
Nikki Fox, project scientist for this mission, to help illustrate Parker's path.
Thanks, Marie. Nikki, thank you for being here.
You're welcome.
So there's so many fascinating things about this mission. One thing that I find particularly interesting is the unusual orbit that Parker's going to take once it launches. Can you explain that?
Yes, once we're in space, it's a very busy first couple of weeks for us. We have to get it commissioned and all ready to go because just 6 weeks after launch, we encounter the planet Venus for the first time. We use Venus to give us a little gravity assist. Basically, it's like a little handbrake turn and it focuses our orbit in towards the sun because we don't want to be dragged around in any way or influenced by the Earth's orbit. And so during our 24 orbits of our 7-year mission, we actually will do these flybys of Venus another 6 times. And each time, as you can see from this animation, our orbit is getting smaller and smaller until those final 3 orbits, we are at our final closest approach.
Speaking of closest approach, can you describe exactly how close the Parker Solar Probe spacecraft is going to get to the sun?
Yes, at our closest approach, we will be 3.83 million miles above the sun's surface. And I realize that you just thought, million? That doesn't sound very close.
Right.
But you know, the Earth and the sun are 93 million miles apart. And so if I put the Earth and the sun in the end zones of a football field, Parker Solar Probe would tuck and run all the way to the sun's 4-yard line, well in the red zone, knocking on the door for a touchdown, right by that goal line.
Well, that sounds extremely close to me. So I'm sure that folks are now wondering, how is a spacecraft not going to burn up at the 4-yard line?
We have a wonderful heat shield that we keep oriented between us and the sun. And so it keeps everything in the main body of the spacecraft nice and cool. It kind of creates a shadow. And it has a white coating on it that was specially designed for Parker Solar Probe, very much like you prefer to be in a white car on a hot day instead of a black car on a hot day. The heat shield is glowing and it is reflecting a lot of the sun's energy. And so the front side of the heat shield gets to about 2,500 degrees Fahrenheit, but everything on the main body in that shadow is at about 85 degrees Fahrenheit. So much like a pleasant Florida evening.
That sounds so lovely. Well, Nikki, thank you so much for being here today. We're all extremely excited about this mission, Go Parker Solar Probe. And with that, Marie, we'll go back to you.
We are coming up on another major milestone in Parker Solar Probe's flight. Let's head back over to Josh for the latest. Josh?
Thank you, Marie. I'm here again with Alyssa Macbeth, and we've been monitoring the flight as it's gone so far. And can you tell us a little about where we are now and what's about to come up next?
Yeah, so as I mentioned earlier, there was two burns of the second stage. So we're about to come up on that second burn. After that, the engines will light and we'll enter that phase, and then they'll cut off and we'll enter into a coast phase right before a second stage separation. Then the third stage will ignite at approximately 37 minutes into the flight, and that will be our last and final burn before spacecraft separation.
So we had a great launch on time this morning at 3:31 a.m., but there's still more work to do.
There is.
Before the spacecraft separates.
Mm-hmm.
And can you tell me what's next for United Launch Alliance?
Yeah, our team is still working they're monitoring data in the launch control room and in Denver as well as here, just looking to make sure everything looks nominal, that the booster performed, they're probably looking at data from the booster and make sure everything looked clear and good there. And as we continue through the flight, they'll continue to do that.
Well, once again, you're looking at a live telemetry feed here. It's an animated feed that you see of the second stage. When at the very top of it, you see NASA's Parker Solar Probe there, which is moving toward its separation time.
Almost.
And we just have confirmation of ignition
firing
of the RL-10 engine. And with that, Alyssa, thank you for joining us today, and thank you for a great launch.
Thanks for having me again.
Yes.
Thanks.
I'm running out of steam.
Body rates continuing to look good, chamber pressure remaining stable. 24 minutes, 5 seconds into flight.
I'm running out of steam and ability to remember to unmute myself. Do we have... do you guys have any questions, or shall we call it a night and let this little spacecraft go with a little less bother as she continues to do her job and make way towards Venus to bring us the science? I know the no camera feels bad.
We are at a mission elapsed time of 24 minutes, 50 seconds into launch. The second burn of the RL-10 engine you see on your screen from the telemetry feed that is updated in real time. We'll continue to monitor things as we move towards spacecraft separation, where Parker Solar Probe will then begin to unfurl its solar wings. But for now, we'll go back to Marie Lewis in the studio. Marie?
All right, thanks, Josh. The Parker Solar Probe mission is designed to collect data and study solar processes that scientists have never seen before. NASA Edge's Blair Allen spoke with mission system ed.
Okay, so thank you all for coming. Thank you all for joining me this evening. And it's just a great night. Thank you, Boo-Roo-Boo. I hope that we see you more and more over on this channel. I do need to get some sleep. I will be back on this channel Monday at 1 p.m. Eastern, which is 10 a.m. Pacific, 6 p.m. London time, and I'll be here to bring you the daily space, our Monday through Friday update on all that is new in space and astronomy. Actually, I think it's going to be Andreas Plazas who's bringing it to you on Monday. He's going to be helping me out next week while I prep to head off to Vienna for the International Astronomical Union meeting. which starts a week from Monday. I will be bringing you news live every Monday through Friday while I'm in Vienna, unless something comes up, which is always possible when traveling. Thank you, Audius. So, as always, give us a follow if you want to get notified when we're going live. We are here to put science in your brain. This channel is part of CosmoQuest.org. We invite you to help us map out other worlds in the solar system, mapping craters and other features in images obtained by a variety of different NASA spacecraft. Anytime you have some spare time and spare screen real estate, we have science for you to do. Fenmill, I will probably not have Vienna sausages because they really don't have Vienna sausages in Vienna. But I will have sausages that are not the same as Vienna sausages in Vienna. I do not like schnitzel. I really don't. Personal problem, however. Anyways, I will be back, or Andreas Plazas will be back on Monday with the Daily Space, bringing you highlights of all that is new in space and astronomy. This channel is a collaboration between the Astronomical Society of the Pacific, the Planetary Science Institute, and Youngstown State University. Give us a follow. Follows are free and will always let you know when we're starting. So thank you. I will see you all on the other side. Yes, Fenmill, you did kind of break me. So go out if it's still dark where you are. Catch a few Perseids and then call it a morning, evening, or afternoon. And either dream well when you get there or live those dreams if it's daylight where you are. Bye-bye, everyone.